My name is Julie Shapiro, and today I'm going to be talking about a scale for quantifying behavior based on aggressiveness in bats. I've been working with bats for about 15 years now, and I've always noticed that there's a lot of variation in the way they react to being captured. Some of them, when you hold them, go pretty much crazy and want to destroy you, while other bats stay really calm and you barely even have to hold on to them. And this made me wonder if we can quantify this variation in aggressiveness, both between individuals as well as different species, and how this might connect to other personality traits or aspects of bat ecology. Now, scales have been around for a long time. They're a really low-tech method. For example, this paper from 1941 used a scale to quantify differences in aggressiveness in laboratory rats. And now, scales are a lot less commonly used for wild-caught animals, although I did find this paper from 1969 that used a scale to measure aggressiveness in wild-caught blackbirds. Now, why is a scale useful for studying bats? Well, it's an easy and simple method, relatively speaking. There's no need for extra equipment or investment. There's no need to keep bats in specialized facilities. For example, other studies of personality traits in bats have either observed bats in colonies over long periods of time or captured bats and brought them to specialized facilities to perform in behavioral assays. A scale could be easily integrated into the standard processing of bats that are captured for any kind of study. And it could also be used to collect data across different bat species and geography. Aggressiveness is a really useful trait to base a scale off of for bats. It's ecologically relevant. Bats use displays of aggression towards conspecifics to establish dominance and position in roosts. It could also be interpreted as a response to predators. Aggressiveness is also shown by bats through easily identifiable behaviors such as struggling, teeth-baring, and biting. And this teeth-baring and biting are also the same behaviors that they'll use towards conspecifics in a more natural context. So here is the scale that I devised based on 5 different levels of aggression. At the first level, we have bats that are completely calm, with little to no movement, no struggling, biting, or trying to escape, and their mouth stays closed. Level 2 bats will exhibit some struggling with movement of the body, arms, or wings, but they don't attempt to bite and the movements are intermittent. Their mouth stays closed. Level 3 bats are struggling intermittently with movements of the body, arms, or wings. The bat opens its mouth and bares its teeth, but doesn't actively try to bite. Level 4 bats engage in continuous struggling during handling with strong movements of the body, arms, and wings. In addition to baring their teeth, the bat occasionally gnashes its teeth or attempts to bite the handler or equipment, such as calipers. And finally, the most aggressive, level 5, bats that are continuously and aggressively struggling with their body, arms, and wings. They're continuously gnashing their teeth and biting throughout handling. Now, I had some questions on how to best implement this scale. First, I knew that it was probably best to have multiple observers. So first, the handler as well as a second observer. And then I wasn't sure how best to score. I could think of either giving one overall score for each bat during handling, or creating a mean score based on scores given during different stages of handling. For example, with bats, it's pretty standard to take certain measurements, such as a forearm measurement, aging, sexing, and verification of reproductive status. And I could give a score to the bat at each of these stages and then create a mean score. So I tested the scale in Eswatini in 2016. I tested it using 35 different individual wild-caught bats belonging to 3 different species. Most of them were little free-tailed bats, as well as a few African yellow bats and pipistrelloid bats. And I compared the consistency between the handler, myself, and a second observer for both this overall score as well as stage scoring using interclass correlation coefficient. I found that scores between the handler and the second observer were most consistent using a score that was given in stages compared to the overall score. The ICC of 0.79 showed excellent agreement, whereas the ICC for the overall score was quite a bit lower and also had wider confidence intervals. I think this might be because giving an overall score might be biased towards observations at the beginning or the end of handling, and also giving these scoring in stages also requires both handler and observer to pay attention to the bat throughout handling. There are a lot of ways that this scale can be improved. First is video recording bats, which would allow observers to measure their own consistency when rescoring bats, as well as allow for scoring by observers who were not present at the original scoring. It would be great to see this scale expanded to other species and locations. And it would be also interesting to repeat trials on individuals to see if they are consistent in their level of aggression. All these bats were caught, scored, and then released, and so there was no way to repeat the trial. If you're interested in this, you can check out our recently published paper in the Journal of Bat Research and Conservation. This is free and open access. And finally, I want to thank everyone who helped with this project, with scoring the bats, help with logistics, as well as discussion on behavioral ecology. And finally, thank my sources of funding, the NSF GRFP, a National Geographic Young Explorers grant, a student research grant from Bat Conservation International, and a grant from the Explorers Club Mammoth Scholars Program. And thank you for listening.